Hi there. In this video, we're going to be talking about simplifying radicals. Now, a radical is an operation that we do that's called the root, okay? Also known as the square root, okay? And so what I want to do is talk about, well, what's a square root? What does that mean? We often see it and that sort of thing. So what I want to do is this. I'm going to take the number 3, okay? And I'm going to square that. Now, what we should hopefully remember is that when I take 3 squared, that means that we are taking 3 times 3, and that gives us the value of 9, okay? So what we know is that 3 squared is equal to 9. But now what I want to do is I want to go backwards. I want to take the square root of 9. And that, all it is the opposite of squaring a number, which gives us 3. All right, so oftentimes, what I ask myself is that when I take a square root, I'm going, what two numbers multiplied by itself gives me the number underneath here, all right? And so this symbol here is called the radical symbol, all right? And that prompts us to take the square root, okay? So that's the idea, all right? And that's what we're going to be doing. And we're going to be simplifying these radicals. And it's important that we understand, first of all, what they are, and then what we're able to do with them, given other kinds of radicals. So what I want to do is talk about a list of numbers that we are going to use called perfect squares that we're going to use to help us simplify radicals. All right, so I want to start off with the number 1, okay? The number 1, if I square 1, that means I'm taking 1 times 1, which gives us 1, all right? And then if we go the opposite direction and take the square root of 1, we get 1. This is a terrible example, okay? But I'm going to do more numbers, but we got to start off with 1 because we know that the square root of 1 is 1. So 1 times 1 gives us 1. Therefore, what two numbers multiply together to give us 1? That's 1, all right? Let's do 2. 2 squared, 2 times 2 gives us 4. And if we take the square root of 4, doing the opposite, it brings us back to 2, okay? So 3 squared, we already did that one, that's 9. We know that if we take the square root of 9, we're going to get 3. If I take 4 squared, all right, 4 times 4 is 16. Therefore, if I take the square root of 16, that's going to give me 4. All right, 5 squared, 5 times 5 is 25. Therefore, the square root of 25 is equal to 5, all right? Let's continue on. Let's do 6 squared. So 6 times 6 is 36. The opposite of squaring 6, to take the square root of 36, brings us back to 6. All right, 7 squared gives us 49. Therefore, the square root of 49 is equal to 7. All right, if I take 8 squared, that's going to give me 64. All right, if I take the square root of 64, that's going to bring me back to 8. 9 squared is equal to 81. 9 times 9 is 81. Therefore, the square root of 81 brings us back to 9. All right, 10 squared, 10 times 10 is 100. Therefore, the square root of 100 brings us back to 10. If we do 11 squared, 11 times 11, that's 121. All right, therefore, the square root of 121 brings us back to 11. 12 squared is 12 times 12, which is 144. And then, therefore, the square root of 144 brings us back to 12. 13 squared, 13 times 13 is 169. All right, if I take the square root of 169, that brings us back to 13. Okay, I'm going to do 2 more numbers. All right, I'm going to do 14 squared, which 14 times 14 is 196. Therefore, the square root of 196 brings us back to 14. All right, if I do 15 squared, and this is where we'll stop, 15 times 15 gives us 225. Therefore, the square root of 225 brings us back to 15. You're probably wondering, why am I doing this? Well, I did it for 2 reasons. I wanted to demonstrate to you, what I'm doing here. with the square roots, okay? But I also wanted to generate this list of numbers, and it's important that you have this number written down, all right? All these numbers written down because, these values here, 1, 4, 9, 16, 25, 36, 49, 64, all these numbers here are all perfect squares, okay? And so these are numbers that you can take the square root of, okay? And that's the idea. Because at this point, what I want to do is I want to ask you the question, how would you simplify, all right, the square root of 8, okay? Now, if you ask yourself the question, what two numbers multiplied by themselves give you the square root of 8, the answer is that it's not a nice, neat number, okay? I actually can't take the square root of 8 and get something nice out of it, all right? It's not like one of these. 8 is not a perfect square. But what I can do is I can simplify it, all right? And I can take 4. 4 is one of my perfect squares, and 4 divides into 8. And what I can do is I can split up 8 and write it as the product of two radicals. I can say the square root of 4 times the square root of 2. And when you multiply different roots together, or different radicals, you multiply the numbers underneath to get this number, okay? But you can go the opposite and you can split it up. And the reason why I chose 4 is because I can take the square root of 4, all right? From here, I can evaluate the square root of 4 and say that that's 2 times the square root of 2, okay? Now what I'm going to do is I'm going to go into the calculator, I'm going to evaluate square root of 8 and evaluate 2 times the square root of 2 and give you guys a decimal value for those numbers. So when I plugged the square root of 8 into my calculator, it will give me a decimal approximation, okay? But understand that when I simplify this and get this in simplest form, I get 2 times the square root of 2, and when I plug that into my calculator, I get the same decimal value. Okay, so there's a way to check yourself if you don't know if you're correct by plugging in your original square root into the calculator, plugging in your simplified version into that calculator, and determining if you have the same value. Okay, in this case we do, so we're good. All right, so I want to do another one. Okay, the next one I want to do is I want to do the square root of 48. Now, I'm actually going to do this 2 different ways, okay? Because when we do this, you can look at it a couple different ways. As I look to see which of these numbers, which of these perfect squares divide into 48, I want to look at this, and then the first thing that I see is that 4 divides into 48. So I'm going to rewrite this and split this up as the square root of 4 times the square root of 12, all right? So once you divide, once you figure out what number goes into this number, which of these perfect squares goes into your radical, you have to think about, all right, well, if I divide by 4, what am I left with? All right, and that's where I get the 12. All right, so then I can evaluate the square root of 4 to give me 2. So 2 times the square root of 12. Now, I can go a little further than this because I know that 4 also goes into 12. I can simplify this radical further. And so now I've got 2 times, I'm going to split this up into the square root of 4 times the square root of 3. Okay, I can evaluate the square root of 4, and I can't simplify 3 any further. There's no perfect square that's going to divide into 3. So I'm then going to write 2 times the square root of 3, and 2 times 2 is going to give us 4 times the square root of 3. And this is my final answer, okay? So now what I want to do is I'm going to show you another way to do this, all right? Because as we look over in this column of numbers, 4 is not the only number that goes into 48. The other perfect square that goes in is 16. So if I realize that, I can say, all right, well, I know that 16 goes in, and that's a perfect square. I can write the square root of 16 times the square root of 3. And the square root of 16, I can evaluate that, and that gives me 4, and we're left with the square root of 3. So both of these numbers are the same. Doesn't matter, how we get there as long as we actually arrive at our answer, and that's the idea. Okay, so I'm going to do one more example, and then call this, end the video. But it's this process that you have to go through to simplify square roots. So with 150, the last one I want to do is the square root of 150, and we have to look in this group of numbers and determine which of these numbers can divide into 150. And what I notice here is I have this 25 here, and I know that 25 will, okay? But I have to break this up, and I have to take 150 divided by 25. That's going to give me 6. So if I take the square root of 25, multiply it by the square root of 6, all right, I can evaluate the square root of 25, and that gives me 5, times then the square root of 6, which I can't simplify that any further. All right, the only numbers that are going to divide into 6 are 1, 2, 3, and 6, and none of those numbers are in my list of perfect squares. Okay, so this takes time, this takes practice, but as long as you are follow this method as to how to simplify radicals, this is something that can truly help. So hope you enjoyed this video. Let me know if you have any questions, and we'll see you soon. Thanks. Bye.